Okay, welcome back. What we want to look at today is scatter graphs and correlations. Now, you need to do additional research for this purpose, and you need to look at the work you may be doing in class as well. Okay, and do some additional research. It's all there on the web. Okay, and you have a title here already that you can look up on the web. Okay, and they give some good examples. Look into some of your math books. Especially if you're at college, you can use the math books from the library. Okay, they give some good examples, so use those. Okay, let's have a look. That's what we're going to be covering. Okay, and here we have scatter graphs. Okay, now these are used to see if there is a relationship or correlation between two sets of data. Okay, do tall people weigh more than small people? If there is more rain, will there be less sunshine? If you revise longer, will you get a higher mark? Do small parents have small children? Okay, and here we have our questioning. Now these are just information to see about how we can going to create our scatter graph. Okay, keywords, correlation. The relationship between two variables. Scatter. A graph used to see if there is correlation in respect of one set of data is plotted on the horizontal axis and the other set of data is plotted on the vertical axis. Let me just go and make sure you can see this in full. Okay. Okay. Let me just pan back a bit, make sure we have it in full screen. Okay. On the next few slides are examples of different, well, we don't need to read that. You'll see them coming up in a moment. Okay. Right, scatter graph. Strong positive correlation. Now, scores in science and mathematics test. Mathematics, science. Now, positive correlation between the performance in science and maths. Okay. And it's just showing you that so much in respect of science and mathematics, the scores are almost similar. That's what it's trying to say, basically. Okay. But be sure that you do a bit of reading for yourselves. Do not just take it as read from here. Okay. Do some groundwork. Now here you have strong negative correlation. Okay, and you can see here that the graph is actually declining, whereas let me just go back a little bit. Okay, here you can see that the graph is actually rising in a sense. Okay, and this is simply between rainfall and temperature, purely for illustration again. Okay. Scatter graphs, weak positive correlation. Okay, it's down, it's up, it's down, falling, etc. Okay, literature, scores in English and language and literature, literature can again now you again need to do some groundwork for yourselves. Do not just take this as read. Okay, it only provides you the illustration and pictorial representation as to what a scatter graph would look like. Okay, and that's all this is showing you, how scatter graphs can be used. Okay, and here you can have no correlation in regards to the millimeters of rainfall and hours of sunshine. Investigate whether there is any correlation between height and arm span. Measure everyone's height and arm span. Plot the measurements on a scatter graph. Now, not everyone, okay? Just we're going to assume that it's the number of people in the classroom that you're going to be using, okay? So make sure you can see this and that this comes into play before. Okay. Pan out. Okay. Now the marks of 7 pupils in 2 maths papers are as follows. Plot the marks on a scatter graph. Paper 1 marks on the horizontal axis and paper 2 marks on the vertical axis. Is there any correlation between the marks on paper 1 and paper 2? Let's have a look. Okay, and here's our next question, okay? And look at the answers. Yes, there is positive correlation between paper 1 and paper 2. You can see in paper 1 we have 20, paper 2 almost a similar marking, okay? Paper 1 against paper 2, again, it will correlate to here, okay? Have we got correlation near enough here, okay? So yes, there is positive correlation between paper 1 and paper 2, and you can see it is rising in respect of each paper in turn. So now let's look at the next question. Hang on, sorry, let me just go back a little bit. I'm sure we had 2 questions. Okay. Yes, we are. Okay, that's fine. Thank you. Excellent. Just to make sure I was looking at the right thing. Yeah. Okay. And you can see here that in this case it's a negative correlation between engine size and the distance traveled on 1 liter of petrol. So engine size in milliliters, we don't have a 500 milliliters, but we do have 1,000 milliliters, maybe 800. Yeah, 800 milliliter engine size, okay. Now I have no idea why they've put this engine size as milliliters when in my view it should be cubic centimeters. Because engine size is done in cubic centimeters, but maybe milliliters would be the fuel used. Okay, yeah, but distance traveled 1,500, none. 1,600 would travel 10 kilometers. So the smaller CC engine has traveled the furthest in this case, based on that information, but I'm still a little bit dubious. But don't forget, do some research for yourselves, make sure that you understand the concept, because the way data is presented does not always come out the way it's intended. So remember that, okay? A line of best fit is a line drawn in the middle of a scatter graph which shows correlation. The line is an estimate and used to predict data. Okay, again here we're looking at line of best fit. Using the line of best fit, we can estimate Eve's score on test B as being 6. For test A, it will also be 6. Okay. And again, Amy achieves score of 10 on test B. The line of best fit will be used to give an estimate. Okay, so again, don't need me to do much on this. Okay, just again, do some groundwork for yourselves. Okay, and again here, I'm not going to do anything on this. This is just now for you to look at and to take into account for yourselves. Okay. And here, all you're doing here now is looking at where for a given size engine, is looking at 6.6 kilometers. Okay, thank you. I hope you found this useful. Have a good day. Bye-bye.